গুড মর্নিং স্টুডেন্ট। আমরা আগের ভিডিওতে দেখেছি এয়ার পলিউশন এবং এয়ার পলিউটেন্ট সম্পর্কে। এই ভিডিওতে আমরা দেখব এয়ার পলিউশন কন্ট্রোল সম্পর্কে। সো এয়ার পলিউশন control, there are two types, that is gaseous control and another is particulate matter control. Now we discussed in particulate matter control from the emissions. Now, particulate pollutants basically controlled by cyclone filter and a liquid scrubbing and electrostatic precipitation, that is ESP system. Now, settling chamber is a very vital point for particulate matter control. That is, settling chamber use the force of gravity to remove solid particles. The gas chamber enters a chamber where the velocity of the gas is reduced. Large particles drop out of the gas and are recollected in hopper. It is a simple diagram of a simple gravity settling chamber. Basically, settling chamber is simplest, cheapest, and no moving parts, but it has least efficiency because only large particles are removed and create solid waste system. Because settling chambers are effective in removing only large particles, they are used in conjugation with a more efficient control device. It is a diagram of cyclone. সাইক্লোন হচ্ছে আমরা এর আগে দেখেছি আগের স্লাইডে যে সাইক্লোন আমরা ইউজ করি পার্টিকুলেট ম্যাটার রিমুভের জন্য। নাও সাইক্লোন, the general principle of interior separation is that the particulate laden gas is formed to change direction. As gas changes direction, the interior of the particles causes them to continue in the original direction and be separated from the gas stream. The wall of the cyclone narrow toward the bottom of the unit, allowing the particles to be collected in a hopper. The large air leaves the cyclone through the top of the chamber, flowing upward in a spiral vortex formed with a downward moving spiral. Cyclones are efficient in removing large particles but are not as efficient with similar particles. For this reason, they are used with other particulate control devices. It is a diagram of cyclone and the cyclone installation at woodworking plant. Now, what are the advantages and disadvantages of cyclones? The advantages is low capital cost, ability to operate at a high temperature, low pressure drop, etc. And disadvantages of cyclone are low collection efficiencies and higher operating costs. Now, standard cyclone dimension. There are extensive work has been done to determine in what manner dimensions of cyclone affect performance. In some classic work that is still used today, Shepard and Lappel in 1939 and 1940 respectively, determined optimal dimensions for cyclone. Subsequent investigators reported similar work, and the so-called standard cyclone were born. All dimensions are related to the body diameter of the cyclone so that the results can be applied generally. This table summarize the dimension of standard cyclone of three type three types mentioned in the previous figure. The side figure illustrates the various dimensions used in this table. Now, collection efficiency calculation. have some method, and a very simple model can be used to determine the effects of both cyclone design and operation on collection efficiency. In this model, gas spins through a number n of revolutions in the outer vortex. The value of n can be approximated as the sum of revolutions inside the body and inside the cone. That is n equals to 1 by h lb plus lc by 2. What is n? N is number of turns inside the device. H is height of inlet duct, and lb is length of clone body, and lc is length of cyclone cone. Now, to be collected particles must strike the wall within the amount of time that the gas travels in the outer vortex. The gas residence time in the outer vortex is delta t, that is path length by speed, and where delta t equals to time spent by gas during spelling descent, that unit is second. D is the cyclone body diameter, Vt is gas inlet velocity, and Q is volumetric inflow, and W is width of inlet. Now, the maximum radius distance traveled by any particle is width of the inlet duct W. The centrifugal force quickly accelerates the particle to its thermal velocity in the outward direction with the opposite drag force equaling the centrifugal force. The thermal velocity that will just allow a particle initially at a distance W uh, away from the wall to be collected in time is Vt equals to W by delta T, where Vt equals to particle drift velocity in the radial direction. That his unit is meter per second or feet per second. At least the here the equation, that is Vt is represent here, that is Vt equals to terminal velocity, dp equals to diameter of the particle, and del p equals to the density of the particle, and mu equals to air viscosity. Now, substitution of the second equation into the third elements delta t, then setting the two expression for Vt equal to each other and rearranging to resolve a particle diameter, we obtain dp equals to 9 mu w by pi nvi into rho p minus rho a. Okay, thank you class.